Hey guys, so today we're going to do literal equations. This is where we use the equations or inverse rules to find unknowns. Now, the difference with literal equations to the normal equations that you've probably seen are that literal equations are normally a pre-existing formula or letters or majority of letters rather than the numbers that you normally see, but the same rules apply. So let's go through example 1. Example 1 says w equals x minus y over 2, and we need to solve this for x. That means we need to get x by itself. So just like normal, to get x by itself, the first thing I'm going to do here is multiply both sides by 2 because it's divided by 2 to begin with. So I'm going to multiply both sides by 2. That leaves me with 2w equals x minus y. Now, to get x by itself, I still have the minus y there. So the inverse, or the opposite of minus y, is to plus y on both sides. And they cancel out on that side. So I'm left with 2w plus y equals x. Therefore, x equals 2w plus y. So essentially, I've now got a solution where x is by itself, and I've solved this for x. I've got an x by itself. That there is a literal equation. It's important to note that this end result is the same as the original formula, but it's just rearranged. They're equivalent. So although we've rearranged things, it's still the same formula. Let's do another example. Here, we have to solve it for x. Now, x is, as you can see, let me just use it, x is right there. That's what I want to get by itself. But it's important to note here, I don't need to expand brackets. This is the same as a times x plus 2. Remember, there's a times and then equals y. So I can divide both sides by a because the opposite of times is divide. Divided by a, divided by a. So now I'm left with x plus 2 equals y over a, or y divided by a, same thing. Now, I need to get rid of that plus 2, so I'm going to minus 2 on both sides. X equals y over a minus 2. And that there is my final result as x is by itself. Hopefully this helped you. If you have any questions, please don't hesitate to ask.